Hello everyone, welcome to my channel. In today's video, we're going to answer the question of determining the resultant force on the bolt. The bolt has four forces acting on it: a 60 Newton force, 120 Newton force, a 150 Newton force, and a 70 Newton force. The resultant is going to replace all these forces with an equivalent force that is equal in magnitude and in the right direction. Another way of saying the resultant force is by saying add all the components of the forces. Each force has an x component and a y component. So if I have, let's say, force over here, call it F2, it will have an F2x and an F2y. If I move this F2y so it connects F2x and F2, I would have a right angle triangle. So the way to find the magnitude of F2x and F2y is by using trigonometry. So F2x is going to be equal to, if this is theta, F2 cosine theta. And F2y is going to be equal to F2 sine of theta. So if it's hard for you to remember this, you can simply use cosine of theta is going to be equal to the adjacent side over the hypotenuse. In this case, the adjacent side is F2x, the hypotenuse is F2. I know what F2 is, I know what cosine of theta is, so if I want F2x, is going to be equal to F2 times cosine of theta. Now, in the diagram, I labeled my forces as F1, F2, F3, and F4. And now I'm going to break each force into its x components and y components, and then add all the components, x components and y components, and use those to get the resultant force and the direction of the resultant force. So I'm going to start with force F1. F1x is going to be equal to F1 sine 20. Now I have to be careful because F1 is pointing that way, F1y is positive, but F1x is negative because it's pointing to the left. So I'll add a negative over here, and the magnitude of this is 60 newtons times sine of 20. I'll calculate that number later. F1y it is positive, so it's F1 cosine of 20. Since I'm positive this is sine, this should be cosine. And the magnitude of that is 60 times cosine of 20. Now moving on to F2. F2x is going to be equal to F2 cosine of 60 degrees, which is equal to 120 newtons times cosine 60 degrees, and F2y is going to be equal, it is positive, so it's F2 sine 60 degrees, which is equal to 120 newtons times sine 60. Now moving on to F3. F3 lies on the x-axis, so it only has an x component. So F3x is going to be equal to 150 newtons. There's no F3y component. Now moving on to F4. F4 is also tricky because if I look at F4, I know that the F4x is positive, but the F4y is negative. So I have to pay attention. So F4x is going to be equal to F4 cosine 70 degrees, which is equal to 30 degrees. 30 degrees. F4 is 70 newtons times cosine of 30, and F4y is equal to negative sign because it's negative, F4 sine of 30 degrees, which is equal to 70 newtons times sine 30 degrees. Now I'm going to take a second and calculate all these values. Now that I've calculated all the values of my component forces, I'm going to make a small table of x components, y components, and put all my values in so I can add them in an organized fashion. So I have F1, F2, F3, F4. So I put all my values in the table. I need to pay attention that I always put the negative signs where there's negative, and all I have to do is add all the x components and then add all the y components. So if I add them, I'll get a total of 250 newtons in the x direction and 125.3 newtons in the y direction. So if I draw that, it would look like 250, that is my resultant x, and 125, that is my resultant y. And I'm going to use a formula equation to give me my resultant force. And the formula is that my resultant force, R, is equal to the square root of my resultant x squared plus my resultant y squared. And if I plug numbers in, that is 250 newtons squared plus 125.3 newtons squared, and that will give me a value of 279.6 newtons. Now I know that my resultant force that I got from adding all the components is 279, but I do not know what direction it is in. This is my x-axis, y-axis, this is my resultant force. And to find the direction of the resultant force, I can just use trigonometry. Let's say this is angle theta. I know that tan theta is equal to the opposite over adjacent, which is equal to, opposite is ry over adjacent, which is rx. I know what ry is, I know what ry, rx is over here, ry is over here. I know what ry is, I know what rx is, and I just need to find what that angle is. So I can use tan inverse of ry over rx, which will give me my angle theta. So that is tan inverse of ry, which is 125.3 newtons, divided by 250, and that will give me a value of 26.6 degrees. So I know my resultant force is going to be equal to 279.6 newtons. That is, and the direction is 27.6 degrees to the x-axis. 26.6 degrees, sorry, to the x-axis. Now, to make sure that my answer looks right, I go back to my original diagram and I look. My resultant force is much bigger than these. It is almost 279. So does that make sense? And it does, because if I look, I have a big force, 120 force over here, and 150 force over here that are both in the same direction. So my x force should be big. Now looking at my y force, I see that I have a 120 component that has a y component. The 60 Newton force has a y component. So I know, and I have a negative y component, but these two forces are bigger. So my force should be upwards. My y component force should be upwards, and it is. So that gives me a sense that my force, my resultant force is right, and that I did the problem right. Thank you for watching my video. Subscribe and like for more new videos.